Hi, this is Austin with Sprint 3, so I will go ahead and launch this real quick so that you can see the actual thing. So, first is the AABB, and this is actually the more broken one, so I'm not sure why I'm showing you this one first, but let me turn, and then you can see the collision. You can see the bullet is coming out, so I'll go ahead and frame by frame. The bullet should hit me first. That one should be right on. You can see I lost the health. The bullet's still there because it's waiting to despawn, and it just despawned. And then I accidentally turned off the frame by frame, but that guy should it's weird. It's like it depends on the angle it hits me from. Sometimes it dies right away. Sometimes it'll go a decent ways into the box before it dies. And I think that's a problem with the data that I'm setting down here. The half diagonal, center, and scale square. Because if I change the enemy to OBB here and then go again, it works pretty much perfectly, and I will show that. Because I feel like that's the more important part. If I can figure out the correct way to calculate the half diagonal, that'll take 5 seconds to fix. So let me loop around, Control F10, F9. I'll let the bullet hit me. Same deal. This guy's going to inch his way up slowly, and right about now, yeah, he hits me the moment he crosses in. You can notice that that's already changed, and then he despawns. And I'll just cruise around to try and hit some of these other guys to show you that it's pretty much pixel perfect. All those pretty much died as soon as they were supposed to, so that's working really well. So let me get rid of the enemy. I don't need to look at that. So the only thing I changed with the collision volume was I added an initialize data function that I could use to set the half diagonal only once on the first frame rather than doing it every frame, and that's called the first turn, or the first frame rather than compute data. But it also tends to call compute data from within, like here in the AABB, and the OOB, or the OBB also does that. But anyway, I want to show the collision volume box where it has all the data structures, or the data variables, that is, and some gets for all of those. I also have a attorney that I can use to get the regular world for calculations and the adjusted world for the visualizer. The AABB is more or less the same, just with the three things I said earlier, and like I said, I don't think I'm calculating these right because the AABB isn't quite there. It's close, but not quite. So I need to reevaluate how to calculate those. But I have the OBB, and this works really nicely, as you saw. So that's just how I calculated that. A lot of this is pretty much straight from the homework back in algebra when we talked about these things. So, yeah, here we are. So show OBB. I have to do a temp variable here because it passes in a const matrix, or a const matrix from get world. But this needs a non-const matrix. So, and then the render OBB is down here as well. And then the math tools, it is just a series of, makes all the vectors that it needs. For both of these are pretty much the same. It makes all the vectors and then checks does the SAT check for all of them. That's a separate function here, which also uses another separate function for projection max. And if you're waiting to comment about my lack of game progress, I actually do have a separate demo because the game changes I made it more difficult to test collision, so I just left that for now. Left that in the separate demo, that is. And then I will now show you the progress that I made with the game. So I have walls now. Also, enemies no longer just suicide into you. They'll stay at a distance. They will pursue if you get too far away. But once they get around you, they'll just stay. And if I get close, this guy will actually start backing away from me. So you can still run into enemies, but they actively discourage you from doing it. I am also going to come over here to one of my walls to show that, well, the main purpose was so that you wouldn't be able to see the endless void anymore. But actually, if I run into this wall, I can't go past it. So, and if the enemies followed me, which they did, I will also demonstrate that they will not go through the wall either. And I'll probably edit this. Okay, so I'm right about there. I'll push this guy up to the wall, and once he gets there, he just stops. Well, he doesn't stop, but he can't go through the wall. So there it is. That's that's the stuff that I added to my game this week. So next I want to show off my personal project, which is saving and loading. So what I'll do is I'll chase this guy over here, because right now it's only endgame saving. So like I'm not writing the file right now. I'll show you. But if I go to a different scene, like so, all I did there was press enter. Then this would be like a pause screen, and once I unpause, he will remain over there. Position and all that should all remain the same. Position, color of box, rotation, and scale are the 4 that I'm serializing and deserializing right now. So the way I'm doing it is I have a storable class which the enemy inherits from. So right now I'm only it's only built to support a single enemy. I wanted to start small. It has a store function and a recreate function the class does. I also have a manager that, hang on. I also have a manager here, which has a list of storables. And it has store element, which will add the storable to the list once it's created, and then the serialize all, which is just here, it loops through. And then calls store on all of them. So that'll call the enemy store class, which I'll show in a moment. Or the store function, that is. This is, I think, a redundant class, which I was using to keep the buffer in a separate class. I think I can just integrate that into the storable manager, though, but it's still here for the time being, because I was more concerned with getting something working, and I will simplify that when I get the chance. So here we are, the store and recreate. So the store is just a one-line serialization. It should be very simple. And then the recreate creates a temporary new enemy, stores all the values there. And the reason I don't delete the temporary enemy is because its model pointer is bogus. So when it tries to do the destructor, it breaks down. And the reason I don't think that's a problem is because I plan on reworking this to not be creating a temporary enemy. And to just use a separate class, like an entirely new class to serialize and deserialize, and then get my values from that, rather than a separate enemy class. Or a separate instance of the enemy, that is. And last but not least, the scene manager, what it does to allow for... Hang on, I got the wrong scene. To allow for serialization and deserialization is I have a separate recreate function in the scene that is called in place of initialize. It does most of the same stuff, and I'll show that in the base scene, but instead of calling spawn, it'll call override and generate the new enemy all by itself. And the way I determine that is when I store everything, or when I reload everything, I call a function called set recreate, which has this recreate variable, which is a boolean, and when it's true, then it'll call recreate. When it's false, it'll call initialize, and I have a setter for that in the .h file. So, and I have here a list of future sprint ideas. So, reading and writing from file, merging the classes I talked about, passing in an offset so that I can store multiple enemies in the same buffer and recreate them all using offsets like we did in the serialization assignment in networking. Making a more friendly class that would just contain the data and serializing and deserializing to that, and then getting the data from there for my new enemy. Recreate function actually takes different types of objects. It would need to read them in the order they're serialized and then deserialize to the right kind of object. And that would involve a lot more code in the scene recreate function, like the base scene that is not the regular scene. And then adjusting it so that I can store alarms and possibly inputs as well, were my various ideas. And then probably as a 1 week side project here, because I couldn't really think of anything else I'd want to do with the loading and saving here. So I know you're going to show up a simple particle system in class, and I might pick that up on that last week. Since I don't know that this is going to be enough to carry me through, I don't want to spread this out too much to make it too easy. And so that's my game plan. I think I said everything I needed to say. So hopefully this is looking better than what I had last week. So talk to you next time.